Hello everyone and welcome back to mathMinutes. In this video, we have an exciting topic to explore: prime numbers and prime factors. Prime numbers are fascinating mathematical entities that have intrigued mathematicians for centuries. So let's dive right in and discover the secrets behind these special numbers. To begin, let's define what prime numbers are. Prime numbers are natural numbers greater than 1 that are only divisible by 1 and themselves. In other words, they have no other factors apart from 1 and the number itself. For instance, let's take the number 5 and find its factors. We begin by dividing 5 by 1, which gives us 5. Then we divide 5 by 2, which does not give us a whole number without a remainder. We continue dividing 5 by 3, 4, and finally 5, and find that 5 is divisible by only 1 and itself. Therefore, 5 is a prime number. A common mistake is to think of 1 as a prime number. The number 1 is a special case which is classed as neither a prime or a composite number. The numbers 2, 3, 5, 7 and 11 are all prime numbers. Check to see this is true by following the same method we have just shown. Note that 2 is the only even prime number. Prime numbers have several unique properties. One of these properties is that they are the building blocks of all other numbers. Any composite number, which is a number that is not prime, can be expressed as a product of prime numbers. This brings us to the concept of prime factors. Prime factors are the prime numbers that multiply together to give us a composite number. Finding the prime factors of a number is like breaking it down into its fundamental building blocks. Let's take an example to understand this better. Suppose we have the number 12. To find the prime factors of 12, we start by dividing it by the smallest prime number, which is 2. Since 12 is divisible by 2, we can write it as 2 times 6. Now, we continue dividing the remaining factor, 6, by the smallest prime number again, which is also 2. This gives us 2 times 2 times 3. Since 3 is a prime number, we can stop here. The prime factorization of 12 is 2 times 2 times 3. We can also write it using exponents as 2 squared times 3. This representation allows us to express any composite number as a unique product of prime factors. Prime factorization is crucial in many mathematical operations and applications. It helps us simplify fractions, find common denominators, calculate the lowest common multiple and the highest common factor, and even encrypt data using prime numbers in cryptography. Now, let's delve deeper on how to find the prime factors of a given number. There are several methods, but one of the most common techniques is called the factor tree. To use the factor tree method, we start by dividing the number into 2 factors. Then, we continue breaking down each factor into its own factors until we can no longer divide them further. The resulting branches of the tree will be the prime factors. Let's demonstrate this with an example and take the number 60. We find any factor pair, so in this case, let's use 6 and 10. Neither of these are prime, so we find factors of both 6 and 10. Since 6 is divisible by 2, it branches down to the factors 2 and 3. Both numbers are prime, so we make sure we circle both. Since 10 is divisible by 2, it branches down to the factors 2 and 5, both of which are prime, so we circle them too. All of the factor tree's branches end in a prime, so we stop here. We write the number 60 as a product of prime factors, 2 times 2 times 3 times 5, which we can write as 2 squared times 3 times 5. That's it for today's video on prime numbers and prime factors. We've explored what prime numbers are, how they are different from composite numbers, and how to find their prime factors using the factor tree method. If you enjoyed this video and want to learn more about fascinating mathematical concepts, don't forget to like this video, subscribe to our channel, and hit the notification bell to stay updated. Also, let us know in the comments if you have any questions or suggestions for future videos. Thanks for watching and see you next time.